Wonder what Mr. Bergman's doing today. It's a strange sound coming from his room.
Hey, Mr. Sams, how you doing?
Not too bad. What are you doing?
I'm practicing.
For what?
Well, I think you'll find out later.
Why does this make me nervous?
I don't know. I don't know why it should make you nervous. I'm getting pretty good at this.
At what? You're just throwing a ball against the board.
Well, you know, you'll see, I guess, huh?
Okay.
All right.
I trust you. Sort of.
Hey, Mr. Sams, my arm's feeling pretty good.
Okay.
Yeah, it's feeling really warmed up for today.
For what?
Something. Something, yeah.
I feel sick to my stomach. I don't even want to know.
You don't know? Okay, that's good that you don't know. Hey,
Can't
today we're
be
going to talk about precision and accuracy. And then there's this other topic, significant figures.
Okay.
So why don't we kind of just dive into it?
Let's do it.
Everybody?
Let's go.
Okay. All right, let's do that. So the first thing I want to do is talk about accuracy. Okay. Do you know what accuracy is?
Well, it's how close you are to a given value or to a target.
Yep, so that's right. So it actually depends upon the measuring device.
All right.
Okay? So if you want to be accurate, you need a good measuring device.
Yeah, you got to make sure it's calibrated. So I mean,
Yeah.
something it can make a very precise measurement to many, many decimal places, but if it's not calibrated properly, then it's not going to be close to the actual value.
So calibrate means it's set correctly. All right? And then precision is a little bit different.
Uh-huh.
So actually, we said this. You've already written down the definitions in your definition section.
Yep.
Precision is how close you are. How close you are to the not how close.
No.
Precision is what?
When you have multiple measurements, if they're precise, they're very close to each other.
Multiple measurements. Let me write that down so everybody else can. Multiple measurements, and they're all close.
Right.
Right.
So that's kind of like the consistency, how consistently something measures, and how consistently something measures a value.
You have an idea, Mr. Sams.
Okay.
I think we should illustrate this. I've been working my arm up, so I think we got a cool little illustration we ought to do right now.
All right, let's give it a shot.
Okay, let's do that. All right.
I'm still nervous.
No, you'll be all right. I think. Okay. What I want to do today is I want to talk about accurate precision, and I've got an interesting experiment today. I'm going to take my safety glasses, I'm going to put them on, and my goal is, of course, to, if you look over here at Mr. Sams, is he has an apple on his head.
I don't think I like this so much. Oh boy.
Oh,
you
okay.
knocked my apple off.
I knocked the apple off. And so the point here is I'm going to attempt to do I don't have my bow and arrow with me, so I'm going to attempt to throw the ball and knock the apple off of his head. So let's see how accurate I am. Okay. All right. Beth Ann, where did I mark? That was not a very good thing. So what would you say about that?
No, that was a good thing.
That was not very accurate, was it? Okay, let me see if I can be accurate. Okay. Oh! Mr. Bergmann, what does he hit? All right, right in the middle. All right, we got the apple. It's on the floor by her foot. Okay. Now, let's just keep doing a couple more trials and talk about accuracy and precision. All right, let's see how good I am. Okay.
He's lost the tennis ball.
I lost the tennis ball. Okay, so, all right, let's do this again. All right. Ow! Put a mark on his head. Oh. The apple fell. Okay.
It doesn't count if you smack me in the face.
I know. All right. Okay, and let's do one more. Okay.
Oh, you got to hit it one more time.
All right,
hit
one
the
more.
apple. Wow. You better stick to running. Oh, there we go. Off the rebound.
All right, let's talk. So, Dr. Boyd, if you zoom in here.
I'm going to go calm myself down now.
These are pretty close to the accurate answer, right? So chemists would say that this right here is accurate. This up here, of course, is not accurate. Hitting me in the face was not accurate either. So these are accurate. But actually, interestingly enough, if you group these three points together, they're considered precise. Okay? Precision is close to the same answer, although not accurate. These three together are precise and accurate. The 3 times I actually hit him. This, of course, is inaccurate and imprecise. It's imprecise because there's only one spot. Hey, Mr. Sams.
Yeah, my head hurts, and I'm going to sit far, far away from you for the rest of the day.
Well, I was close most of the time.
Yeah.
No? Hey.
Well.
Should we talk more about precision and accuracy?
Yeah, I suppose.
Hey, what would you say about this one right here?
I'm thinking that's not really accurate and not real precise.
Not precise and not accurate. That's
Kinda
right.
all over the place.
Not precise or not accurate. So it's not accurate. And it would be not precise, would it?
No, it's all over.
Didn't get the correct
Right,
answer.
they're multiple measurements, but they're not really close to each other.
Yeah. Okay. And what about this
Okay,
one,
no,
Mr. Sams?
those are very precise because they're all close to each other, but they're not accurate. So if, let's say I had a bow and arrow and I was shooting at this target, that means I, as a shooter, am very consistent, but whatever I'm using to sight my shot in, it needs to be recalibrated.
Yeah, my son, he used to shoot bow and arrows competitively, and they would say they were usually happy if they had this kind of a in warm up, because they knew they were actually shooting in the right place, and if they just adjusted just a skosh, they could move it and get lots of bullseyes.
Yeah.
So, okay, and this one, of course, is the best
That's
situation.
accurate and precise.
This is accurate and precise.
Yeah, they're all close together, so they're precise, and they are close to the bullseye or our given value, so they're accurate.
Yeah, cool. All right, so now second topic today. We
Okay.
want to talk about significant figures. Now, what's the point of significant figures?
Well, we are limited by the accuracy of our least accurate measuring device.
So you're only as good as your least accurate measuring device. So everybody, of course, should be writing this down.
Yep, and when we say least accurate, we're talking about like least number of decimal places measured or least number of significant figures measured.
So let's take a look at a quick little video clip that will explain, I think, the point of significant figures. Mr. Bergmann here with the apple. Yeah, it's the same apple. Remember this, Mr. Sam?
I remember the apple.
The apple, right? Mm-hmm. So I've got the apple, but I want to do something with the apple. I don't want to eat it. It's actually kind of nasty. I want to weigh the apple. And so what I brought with me today is I brought 3 scales. I've got a cheap scale that costs approximately $100. I've got a slightly more expensive one, $300, actually triple. And then I happen to have a very expensive balance, approximately $800. And I'm going to put the apple onto 3 different scales. So I'm going to put the apple on the first scale. All right, and I'm going to read the balance so I can see the balance. It's probably hard to see the video. And it weighs 132.2 grams. All right? So we would actually say that this is accurate to, let me write this down here, the number of sig figs, to 4 sig figs. Sig figs, SF. All right? Now I'm going to take the apple, and I'm going to place the apple onto the medium priced balance. Okay. Now, has the apple changed its mass?
Should be the same.
It's the same mass.
You didn't
Guess
take a bite.
what? I see a different number on my balance. I see that it weighs 132.18 grams. Now, has the apple changed its mass?
Well, it looks like it lost 0.02 grams.
Yeah,
if I'm looking at these
kind of
numbers.
looks like it, but can it lose mass?
No, not just sitting there.
Not just sitting there. So what we're actually saying is that this balance is only accurate to 4 significant figures. This balance would be accurate to 5 significant.
Oh, and it costs more, so you pay more money per sig fig.
You get more money per significant digit. That's correct. Or sig fig or significant digit, same thing. These 2 numbers are actually the same number. They're measuring the exact same quantity. You're paying for the extra digit. If you think about this number, the 132, it is actually rounded, isn't it?
It is.
It is a rounded number of the 0.18. Now if I go to my expensive balance, and so if I place it on the expensive balance, and I read its reading, I get 132.184 grams. So for the $800 balance, I paid more money for the extra digit. And the 0.18 is actually rounded of this number, isn't it?
Oh, yeah.
So they round, this number rounds to this, which rounds to this. And of course we would say that this is accurate to 6 significant figures. And you see, we're actually measuring the same thing. Scientists and mathematicians kind of look at the numbers a little bit differently. When you see 132.2, your math teacher would probably say 132.200000, right? Or something like that. That's what you would think. That is wrong when you do measurements. Actually, every number that's a measurement is a rounded number. And the measuring device can get it less and less rounded, but all numbers are rounded. So hopefully that explained that video clip, what we're talking about right here.
All right.
So now let's, actually what you really need to do, there's some rules on counting significant figures.
Yep. Hit pause.
You need to hit pause and just copy
And write these down.
Okay? All non-zeros count. All captive zeros count. All leading zeros don't count. Trailing zeros with a decimal count. Without a decimal, don't count.
Yep, and we'll give you some examples.
We're going to do nothing but examples to the end of this podcast. All right, so let's see if we can count significant digits,
All right.
Mr. Sams. So let's say I have 5.238 grams.
Okay.
How many significant figures are there, Mr.
Well,
Sams?
those are all non-zero digits, so all of those count as significant figures.
So there's a 5.
A 5, a 2, a 3, and an 8.
That
is
would be
4
Yeah.
digits.
Four significant digits. That's pretty easy.
Yeah.
All right, what if I have 5.01?
Okay, that's a captive zero. It's captured between non-zero digits, so that's always significant. So that's 3 significant figures: the 5, the 0, and the 1.
Oh, I'm good with that. All right, we're just hunking there. Okay,
right.
what about 0.0065?
Okay, well, the zeros there are leading zeros. Leading zeros we never count as
Don't
significant
count.
figures. So the only significant figures here are the 6 and the 5. So that's 2
6,
significant
5,
figures.
that's 2. Yeah.
Yeah.
Mhm.
Yeah. Now be careful. Just because we don't consider them significant figures doesn't mean they are not part of the number.
Right.
Okay? This doesn't magically become 65.
Yes.
It's still 0.0065. But in terms of measurement and in terms of accuracy, we say it has 2 significant figures.
Yep, that'd be correct. All right, what about 5.00?
5.00. Those are trailing zeros.
At
Now
the end.
we have two rules for trailing zeros, and the rule is that if they're at the end and there's a decimal point in the number,
Yeah.
then they are
count.
significant. So this has 3 significant figures: the 5 and the 0 and the 0.
Okay, well let's do some more examples.
Okay, let's try
What about 5,000?
Okay, 5,000.
Or 500, yeah.
Okay, so 500. Those are still trailing zeros.
Trailing zeros,
but there's
yeah.
no decimal point in that number.
Oh, I don't see decimal
No,
point.
so that, in this case, the trailing zeros are not significant, so there's only
just
one
one.
significant figure.
So that would just be one significant figure.
right.
That's
So now, again, the zeros are still part of the number.
It's not 5.
But it's not 5, it's 500, but in terms of accuracy, it's accurate to one significant
So what
figure.
this is really saying, guys, is that this number sucks.
Right.
It's been measured very poorly.
Right, so we're talking a measuring device that measures in hundreds, 100 things, 200 things, 300 things,
Yeah.
400 things. Now, to contrast that, 500 decimal,
Oh, yeah, 500 point or decimal, yeah.
that has 3 significant figures. Even though there's trailing zeros, since there's
Because
a decimal
there's
point.
a decimal,
Right.
yeah, mhm.
So this tells us that something is accurate to the ones place. So it measures 498, 499,
Yeah, yeah.
500, 501,
That's
and
kind of like a
502, and
mixed
so
one,
on.
Mr. Sams. What
Okay.
about 0.005030?
Oh boy. So we have leading zeros, trailing zeros,
And
and
captive
captive
zeros.
zeros.
And a decimal.
And a decimal. All right. Leading zeros are never significant.
So
we
these
can,
ones right here
we can rule
don't
those out.
count.
Right.
No. All right.
Now, the captive zero is always significant.
Yeah.
So the 503 we know for sure. So the one in question is the 0 at the end.
Right.
Now, trailing zeros are significant
If
there's
there's
a decimal in the number.
So
there's
it
a
counts.
decimal in this number.
So this would be
5030 are significant, so there are 4 significant figures.
5, the 0, the 3, and the 0. The
and the
ones
0.
you don't count are these 2 zeros here. Let's
Correct.
do one more combination example here. I'll do
All right.
the top here. Let's say I have 501.030 grams or whatever.
Okay, so all the captive zeros are significant.
So that'd be this 0 right here. The question always is what happens to the zeros?
Right. What happens to the zeros?
So those,
everything
because
else
they're
is.
captive, and I got a trailing 0.
The trailing 0 is significant if there's a decimal in the number.
I see a decimal,
That
Mr.
decimal is there, so that's number. The 5, the 0, the 1, the 0, the 3, the 0 are all significant. So we have 6 significant figures.
Well, that's not too bad. I can do
That's
that.
about it.
Okay.
Pretty simple. Just count them up.
All right.
The end.
How's your head?
Hurts.
Yeah, good. I mean, I'm sorry. Yeah.
Thank you.
Yeah, you think. Bye.